Good afternoon. This is David Babson with ARPA-E. Thanks for joining the webinar today on the SMARTFARM program, FOA. The purpose of this webinar is to review the motivation behind the SMARTFARM program, its programmatic elements, and the technical drivers behind phase 2 of the program. The first 20 to 25 minutes of this webinar will go over and highlight the technical targets for the FOA, and the remaining time, the remaining 30 minutes, will be for Q&A at the end of the presentation. Feel free to send your questions through the chat at any time during the presentation. First, a little bit about ARPA-E. ARPA-E funds high-risk, high-impact technology development to seed the next wave of energy technologies with a mission to reduce imports, improve efficiency, and reduce emissions. While modeled after DARPA, an important distinction is ARPA-E's focus on technology commercialization. And as you'll see, from the SMARTFARM program and today's discussion, SMARTFARM is a market-driven program with developments focused and on addressing key technical gaps in existing and emerging carbon markets. In 2018, biofuels made up 10% of the fuel supply in the transportation sector. In addition to being a strategic energy asset in the United States, biofuels provide an economic growth benefit to the nation's farmers and deliver net reductions in greenhouse gas emissions associated with transportation fuels. Looking at the biofuel supply chain, feedstock production is a major contributor to biofuel emissions, and the focus of SMARTFARM is to reduce those emissions. The actual contribution is largely unknown due to the technical difficulty in measuring and tracing the emissions associated with a given feedstock supply. This program seeks to transform these critical upstream stages in the supply chain by developing tools to better track and report emissions so that the entire supply chain can participate in low carbon fuel markets and other existing and emerging carbon markets. These incentives will enable more sustainable practices to be adopted by farmers to drive down emissions and to improve the sustainability of biofuels throughout the entire supply chain. So what goes into a feedstock carbon intensity score? Currently, biofuel feedstock emissions are based on a national average instead of local data. Because of this, growers are not able to participate in the markets aimed at reducing carbon emissions. A major driver of a feedstock emissions is nitrogen. Both the production of nitrogen fertilizers and the loss of those fertilizers as nitrous oxide, which is a potent greenhouse gas, are contributors to the overall carbon intensity. These drivers in feedstock emissions highlight a viable pathway to reducing the carbon intensity of biofuels, which is based on the total life cycle emissions of the fuel divided by its energy content. This also provides the opportunity space for us to see the better measurement of these emissions factors in promoting decisions that will allow reductions of on-farm GHG emissions to move towards more sustainable biofuels downstream. So the SMARTFARM program aims to advance the tools required for measuring the nitrogen efficiency of feedstock production, and in doing so, lay the foundation for financial incentives to promote more efficient practices and the adoption of new technologies. Additionally, the program will pursue development of tools for measuring carbon sequestration in agricultural soils, which would enable growers to participate in existing and emerging carbon markets. With cost-effective and accurate measurement tools, growers can realize the full financial benefits of these market incentives, allowing them to optimize for yield as well as for their carbon services and other attributes that could be measured from measuring the carbon harvest from new technologies to be developed on the farm. For us and for SMARTFARM, program success would unlock these downstream carbon market opportunities and actually extend the incentives that they create throughout the entire supply chain. So looking at a large existing market, for example, the low carbon fuel standard, the profit potential for upstream participation is significant as carbon prices have hovered around 200 megatons, or $200 per ton for the last year. If upstream players could participate in this market and lower their emissions by 30% or more, additional per acre payments of $45 or more are possible. This would be a significant revenue stream for farmers, one that could finance the adoption of new technologies and emissions reduction strategies on farms. So SMARTFARM aims to catalyze these new incentives by advancing the technologies capable of measuring emissions at the field level. If these measurement tools are to be viable in the market, however, both the growers who may adopt them and the market regulators who rely on their outputs must know that these measurements are reliable, accurate, scalable, and they need to be cost effective. This is a technical challenge in and of itself. However, there is also the challenge of demonstrating the effectiveness of these tools in real-world environments. Therefore, if we are to demonstrate the viability of this market pathway, we will need tools that can measure emissions reliably and accurately. And we will need to validate those tools in relevant commercial environments to showcase deployment strategies and real-world operation. So we've developed a phased approach. SMARTFARM has been structured in two phases precisely for this reason. The first phase intends to establish ground truth sites to set emissions baselines in commercial production environments. Doing the costly and laborious work involved, given today's technologies, this is an important first step for having appropriate means to measure success in later phases. The second phase aims to get the same or better degree of accuracy when compared to phase one, while lowering the per acre costs by orders of magnitude. So that's why we need new technologies, is to actually be able to service these measurement capabilities, but at a much, much lower cost. So for phase one, our phase one teams have been selected and are currently in the process of contracting. But here's a preview of the likely locations for the ground truth sites. As you can see, the program will have good geographic coverage and represent key biofuel crops. Each team will be outfitting each of their sites with eddy covariance towers. They will be collecting soil and plant samples at the sub-acre level and incorporating weather and agronomic data to produce field-level estimates of carbon intensity. Phase two teams will be tasked with producing the same high-level output, but at a much lower cost. So the technical challenges are to directly measure nitrogen and carbon flux. Those challenges are numerous, including hardware resiliency and accuracy in indoor environments, system costs, and deployment strategies, which need to be viable under current commercial operating margins and environments. And how all the data being collected are transmitted and reported within a reasonable amount of time are critical. With the nitrogen losses in the form of nitrous oxide and soil carbon being the two primary drivers of a feedstock's net emissions, and the two more difficult to measure parameters, they are the focus of this program. So let me go into each of the categories that we have here. The reason we're focusing on, again, nitrous oxide, this is the primary source of emissions above ground, and soil carbon is the primary means for potentially storing carbon below ground. I would like to note the cells highlighted in orange. These are metrics that have been modified or added to the initial SMARTFARM FOA. N2O emissions are difficult to measure due to the significant spatial and temporal variation in emission spikes and the season-long monitoring requirement to ensure that all emissions are captured. So let's look at each of these boxes here. We have in category one for N2O emissions, the key outputs that need to be assessed, the total nitrogen emissions per season. This is in terms of grams CO2 equivalents per acre per year. There is the dual challenge of holding down the cost to achieve both the spatial resolution necessary for these outputs, but also the temporal resolution over time in changing environments. We have specified metrics associated with the system level uncertainty. We have specified system level variation, spatial resolution, scale, which we've identified to be less than or equal to 80 acres, which is associated with an appropriate size for a commercial farm. We've specified specific failure rates that would be tolerable, as well as system operation cost targets that we want for these systems. Again, the ability to be able to connect, a farmer's carbon harvest, if you will, or its emissions that contribute to the carbon intensity in a manner in which it is valuable to connect those numbers to the markets. We need to be able to identify those data, that number, on a relevant scale and for a low cost. Soil carbon is difficult to measure due to the heterogeneity of soils. Effective sampling strategies are just as important as the hardware or method used to measure important variables in estimating soil carbon, namely the carbon concentration and the bulk density of the soil. So in this particular case, again, going through some of these key things, we've identified the key outputs in metric tons of carbon per acre. We've identified reasonable system level uncertainties, system level variations, measurement depths, which is key. There are some, protocols that are out there that specify, depths of 30 centimeters. Our requirements are somewhat greater than that and should be considered when thinking about the system designs for the measurements that we are interested in getting here. Again, the scale is 80 acres, as well as not just being able to identify the scale at which you measure the carbon in a field, but having access to those measurements for greater than 9 months. So current methods would not avail different parts of an operating commercial farm to soil testing over that number of months in a year. And again, we've also specified cost targets for achieving the relevance of the program's vision as well. As you've seen, the focus and metrics of SMARTFARM are geared toward system-level strategies. It is expected that certain hardware and/or analytical components will need their own development runways, but the purpose of this FOA is to advance system solutions that are relevant to feedstock and fuel carbon markets. For this reason, proposals are expected to provide full description of the system, including, sensing modalities, system deployment, communication, data fusion, as well as how uncertainty will be managed and estimated. It is important to highlight the importance of uncertainty here, as it will be a key factor in the market relevance of SMARTFARM technologies. In the figure shown, there are 3 example systems. Each measures a carbon intensity value of 15 grams of CO2 equivalents per megajoule. That is the measured CI amount, with increasing uncertainty. The project emissions can be credited at the 90th percentile, meaning that there is 90% certainty that local emissions are lower than this value. If we assume a baseline of 30 grams of CO2 equivalents per megajoule and a measured carbon intensity of 15 grams CO2 equivalents per megajoule, the carbon credit for 15 grams reduction would be discounted to a 1410 or 2 gram per CO2 equivalents megajoule based on the standard deviation of the 1, 3, and 10 gram CO2 equivalent megajoules, respectively. So the importance of increasing accuracy and precision simultaneously for outputs in CI have a direct impact on valuing the measured carbon harvest, if you will. Using our 3 example systems, the measured reduction of 15 grams CO2 equivalents per megajoule is lowered based on the degree of uncertainty. For example, the standard deviation equals 10 measurement system, the measured reduction of 15 grams per CO2 equivalents per megajoule, that would get adjusted to 2 grams of CO2 equivalents per megajoule. And as you can see, the per acre payment gets reduced significantly. Additionally, the uncertainty can have a major impact on the per acre profits associated with these carbon market mechanisms, which is highlighted here. Each market has a different method of handling uncertainty, but it will be important for any tool reporting to these markets to be capable of reporting both the estimated emissions or carbon value as well as the uncertainty associated with that value. Before wrapping up, I also want to highlight the kinds of advanced sensors we have seen, some of which are being developed by ARPA-E Open awardees. Sensors to be deployed in highly variable, resource-constrained and dynamic feedstock production environments will need to overcome significant hardware challenges. And the integration, networking, and deployment of these sensors to effectively capture, analyze, and transmit key data sets comes with its own set of challenges that are unique to agricultural systems and to this program. So, SMARTFARM awardees will be expected to overcome all of these technology barriers to produce high-resolution wireless sensing systems capable of capturing the key outputs that will determine a feedstock's carbon intensity. From developing and right-sizing the hardware to be deployed, to ensuring reliable and accurate data capture, to inform field-scale modeling and analysis. Achieving SMARTFARM technical targets will take a coordinated and multidisciplinary effort. We think the effort is more than worthwhile, however, with promising tech-to-market pathways available to successful solutions. So before moving on to the Q&A portion of this session, I want to point out a few resources to those interested in submitting a full application here. So we have the website that will connect folks to the teaming list that has been established for the program, as well as that which you can submit additional questions about the FOA during the open period of it. And I'd like to note the deadline for the full application is 9:30 a.m. Eastern Time on June 23rd, 2020. Now, I was supposed to mention this at the beginning, and I will mention it now, that the host of this meeting is Laura Dimitrian. You can send questions to her. She will get them, and we will respond to them. She's been receiving some, and I'm going to begin going through the questions that we have and answering them in real time. So those of you that do have questions to submit, please submit them to the host, and we will get to them hopefully during the remaining time that we have, or via the community Q&A at a later time. So let's start with what appears to be an administrative question. I guess actually the first question I have right here is, are these slides going to be available afterwards? Yes, not only the slides, these slides will be available afterwards, the recorded webinar itself with the Q&A will be available afterwards as well. So, and the questions to send to Laura, please send those through the WebEx chat. Thank you. So the first question I have is, do the target metrics listed in the FOA need to be met during the funding period, or are they long-term goals? Okay. So the expectation is that teams will submit a proposal describing a technical approach capable of meeting the program goals by the end of the performance period. Next question. This is a technical question. Are funded projects expected to test their technologies at one of the phase 1 ground truthing sites? Yes. So see section 1E for uncertainty measurements. Funds for prototype development and deployment should be included in the project's budget. Next question. Does ARPA-E take any ownership of the IP developed by a company funded by this program? So no, subject to certain conditions and retained government rights. And again, this question, I'm seeing that in section 8 of the SMARTFARM and SMARTFARM SBIR STTR FOAs does clarify that component as well. Next question. Can applicants propose to both categories, N2O emission and soil carbon estimation of phase 2? And if so, should a single proposal package include proposed solution to both categories? Okay. A single proposal may address both categories so long as a single system is being proposed to address those categories. If two separate systems are being developed, one for each category, then two proposals should be submitted. Question, will the performance of the SMARTFARM sensors be assessed more on their accuracy to existing technologies or to their sensitivity for analytics? I can't, and ARPA-E cannot provide guidance on how the metrics of a proposed technology will be assessed during the review. And that will be, some of that will be qualitative assessments based on the external merit reviewers used. Next question, can phase 1 performers participate, prime or subprime, in phase 2 proposals? Yes. This solicitation is open to all applicants. Question, can foreign institutes or companies apply? Yes. See section 3A3 of the SMARTFARM FOA. What type of communication should phase 2 performers expect to have with phase 1 performers? Okay, so phase 1 and phase 2 teams will be encouraged to coordinate early and often in the performance period. Additionally, the phase 1 FOA lists and phase 1 teams are to make their data available to the public and to coordinate and share those data with other performing teams. Okay, next question. Do the technologies need to be demonstrated in farmers' fields, or are research fields, laboratory-based fields acceptable? And then as well as what scale needs to be demonstrated for the actual technologies that are developed in phase 2? So it says that 80 acres in the technical performance targets are what are listed. So systems will need to be demonstrated at one or more of the phase 1 sites, the details of which are listed in section A of the FOA, topic H. For details regarding how the technologies will be evaluated in these environments, also see section 1E for the uncertainty measurements. What are the sensor collection time, response time, update rate, and data latency requirements for soil organic carbon and nitrous oxide? Okay. We did not explicitly set requirements for these timing parameters, although N2O emissions measurement is more dynamic than soil organic carbon. So both have slow responses relative to most interrogation methods. So as a result, we believe the operational cost and system accuracy will dictate these timing requirements. But one additional note on that, at least for nitrous oxide, again, the requirements for the systems to be able to assess the flux of nitrogen over time in a dynamic way to actually be able to get the sum amount for a season is necessary. Are the uncertainty and variation requirements at the sensor sampling level output or system level output? The uncertainty and variation of the outputs are assessed at the systems level. Thus, uncertainty and error need to be propagated to the level of, less than 80 acres measurement estimation output. I have another question here. Is there a pre-application process? There is no pre-application required to submit a full application at this phase. All right. Do the performance requirements need to be demonstrated across the full environmental range conditions? And if you can see, we outlined environmental conditions, including temperature, humidity, wind, etc. And so the answer is yes, the performance requirements do need to be distributed across a range of conditions. All field deployed hardware need to meet the following environmental tolerances. For temperature, it's a range of -10 to 110 degrees Fahrenheit. For wind, it is 50 miles per hour. For humidity, it's 0 to 100%. And then there needs to be, of course, consideration about how the systems would be protected against both rain and dust. Question 3, can you comment on ARPA-E's expectations for application of robust systems engineering practices? Do you want to see an SEMP or an SEP? Answer. ARPA-E expects robust systems engineering practices. Specific system engineering requirements are not included in the FOA. Another question, does the FOA exclude any feedstock? This focus of the FOA is on sensor development, but are expected to demonstrate the sensing tools on a bioenergy relevant feedstock. This goes back to the earlier point about the phase 1 sites that have been selected, the types of crops that were selected in that phase 1. But we do understand that the sensors that are developed could have broad applicability to a range of crops beyond just those bioenergy feedstocks. Okay. What will the phase 2 sensors be compared against? And how will the field test campaigns be scheduled and assigned? So for phase 2 system outputs, the key outputs listed under categories 1 and 2 in the FOA, they will be compared against the key outputs of the phase 1 site at which the phase 2 system is deployed. For both, the output will be aggregated to the field size. So 80 acres or greater, depending on the site. And then field level or field testing campaigns will be scheduled based on phase 2 development time and the timing of the season for the individual phase 1 sites. Prototype systems will need to be ready for deployment in advance of the critical season at whichever phase 1 site is to be used. And there's more information on these specifics in the FOA as well. Here's the next question. Given the small change in soil carbon over time, do you expect the carbon measurements to happen only once a year, like for example after harvest, or do you require the instrument to be able to measure several times per year? Carbon measuring requirement is only limited by cost, accuracy, and uncertainty. But I would note that one of the things that we are interested in terms of seeing in new technologies is engineering for new capacity in soil monitoring that would allow the model to shift to perhaps a third-party verification type of testing. So the ability to be able to go into a field at any time and get measurements would be valuable, even though in terms of actually assessing soil carbon over time, the number of sampling times is not required to be greater than more than time of year. Next question. Will those who haven't submitted concept papers before be able to submit full proposals? Yes. And I will note that this is not typical for most FOAs, but given current circumstances, we wanted to expand the opportunity to accept more proposals in this time. So those who did not participate in the concept paper phase will be able to submit full proposals. So those who have submitted concept papers, can team arrangements be modified post-concept paper submission? Yes, absolutely. Okay, next question. Do you have any limitation in terms of size of the system as well as power consumption? Sensor system size and power are not specified. And again, the metrics that we have outlined, so sensor systems are going to be assessed and restricted by their cost and performance. So those are the metrics that are critical for this funding opportunity. It looks like we're getting a lot of questions about phase 1 and phase 2. I'm going to go back and preview some of the responses we have for those answers. Hold on just a second. Okay, so as a reiteration of what was stated earlier, phase 1 performers can participate as prime or as subcontractors in phase 2 proposals, and the current solicitation is open to all applicants. There will be some communication between phase 2 performers and phase 1 performers. Phase 1 and phase 2 teams will be encouraged to coordinate often in the performance period, and the phase 1 teams will make available data collected from their systems to phase 2 teams and to the public as well. And then finally, in terms of the question about where what will phase 2 sensors be compared against, as was noted, the phase 2 system outputs will be compared against the key outputs from phase 1. All right, next question. Does ARPA-E have access to databases of various kinds of sensor data that can be integrated with data collected from a farm? ARPA-E does not have a database of sensor options and data types to provide to applicants or performers. It appears there are more questions coming, and so we are just waiting for those to be compiled. I appreciate the patience of those that are on this call. So as a general note about more information about the program, about the motivation for it, and our thinking in terms of the development of metrics and those sorts of things, ARPA-E has established a website for this program for SMARTFARM. And on it, there is information related to the program. There are also 2 different program related blogs that have been written. One that outlines kind of the vision for the program as a whole, and one that focuses on the technologies that we seek to establish in this phase 2 of the program. Both of those are publicly available, and there's more information about the phase 1 sites on the website as well. All right, next question. Are cost share requirements triggered if industry partners join as unfunded partners? And the answer is cost share requirements for proposals with and without industry partners are specified in each of the FOAs. And they are dependent upon what type of entity is the primary. Okay, next question. Given that many of these sensing approaches are new, how much effort in the proposal can be dedicated to high precision ground truthing activities that are too expensive for the final system, but can demonstrate the sensing system is giving accurate values? That's a good question. Ground truth data will be provided and compared against by phase 1 performers. So the effort from individual teams for those comparisons are somewhat less important. Okay, just wanted to reiterate, as there's been a couple additional questions in this front, that this is a unique funding opportunity in that we can receive and you can submit full proposals having not participated in the concept paper phase. Now, those that did participate in the concept paper phase did have those concept papers reviewed and have received feedback from us. Those that did submit concept papers and did have those reviewed and received feedback can change up their proposals in ways that they couldn't in other cases to expand scope or to consider additional proposals, components as well. All right, next question. The set operation cost of less than $50 per acre at commercial scale for into a detection system should be understood as the only total of material and labor cost of the system, or is it an expected price tag that also includes the margin for a business? Okay, so the operational cost target should only include the material and labor costs for the system, not including the margin for a business. That's a good question. There have been a couple questions about what information from the phase 1 sites will be available. And let me note that we are still contracting with the teams that are going to be performers in phase 1. So we don't have a full detailed list, but the certain types of things that can be expected, just from the intent of the phase 1 would include data associated with the flux and temporal dynamics of nitrous oxide above ground, as well as measured soil organic carbon below ground for a number of sites. All right, next question. Is it permissible to discuss potential responses with ARPA-E program directors? So I am not able to discuss specific concepts at this time, nor are other ARPA-E program directors. All questions that you have about this FOA until after the end of the writing phase, till the deadline passes, all questions must be submitted to the FAQ email address that I provided in the presentation. Let me clarify that the time I mentioned for answering questions from ARPA-E program directors, the deadline date for the proposals is still not the end date by which we have limited communication. That must continue to go through the contracting officer and through the FAQ email address that was given until selection and rejection notifications have been sent. Okay, so next question. Is ARPA-E expecting a value of carbon gain per acre per year? Are also where it goes within the soil profile. So this is a good question. We want the ability to measure this. So we expect a measurable carbon value change per year with the proposed technology. Now, any insight on the source of the carbon change and change within the soil profile would be helpful information, but it's not included in the FOA. So the technology development is for being able to precisely assess changes in soil carbon, not necessarily and not at all to necessarily associate that change to some other factors. I'm going to go back one slide to provide you the information where you can see the teaming lists, as well as you can see the email for sending in additional questions after this webinar through the contracting team, just so that's up on your screen and it's available. I have one additional question. Where do we find information on the phase 1 funded projects? And that is, there is a list of the selected phase 1 projects available on the ARPA-E website. And this link will be posted in the FAQs soon. We're reaching near the end of our time. We're going to see if there's any additional questions to compile. Okay. Here's a question. It's a clarification about system operation cost. The price quoted is at commercial scale, but systems will still be in development phase. How do you reconcile this with the earlier statement of having to meet all requirements listed? Okay, so while the proposed program is at the R&D stage, we need a price walk to get the estimated cost from R&D cost to targeted commercial costs. And then, additional discussions in terms of, kind of rectifying those two things as part of the tech to market strategy can be discussed at a later date, or as we get more information down the road. Might have one additional question. This question asks for me to elaborate more on the system cost issue. How can teams calculate the amortization of higher costs over the lifetime of the systems? So amortization of higher costs over the lifetime of the system can be estimated or assumed in the proposal at this time, as long as the authors state how it is estimated and provide any of the assumptions made. So we are at the 2 p.m. mark, and I want to be respectful of everyone's time. Again, let me draw your attention to the slide that's up on your screen now. It provides the email for submitting additional questions that will be answered as part of the frequently asked question inbox that will be updated. Please note that these slides will be available afterwards, as well as the recording of this webinar. And we appreciate your time and look forward to seeing full applications in the next couple months. So thanks for joining today.